Hello everyone, today in this video we'll be discussing the module 2 of microcontroller BCS402, and in this module we have the following topics. There are different instruction types. Okay, instruction means what? Doing something. Okay, what the computer needs to do, that is called as instructions. So there are different types of instruction for different purposes that we'll be discussing in depth, and if you watch this video till the end, easily you can score more than 80% marks. Don't miss any of the topics, watch it till the end. And before starting, please like and subscribe, it helps me make more videos like this. And if you have any questions or queries, you can DM me on Instagram. Here's my ID. Okay, so the first topic is introduction to the ARM instruction set. Okay, now we'll be learning about the instruction set which is present. What are the keywords we will be using? Okay, to do something we need to specify what we need to do. Okay, and that has a syntax. Okay, the keywords we'll be using to perform an instruction. So these are the keywords. It's a very big list. You need not memorize all of them, you just need to know a few of them. Okay, so I'll be telling you which all you need to know in the upcoming topics, but understand what it is. Okay, it is called as add. Okay, add means adding two numbers. Okay, the description is given here. And BIC means bit and clear. Okay, logical bit clear. We'll be seeing the examples of the important ones which are asked in exam. So these are the keywords. Okay, like the specifications of the code words which if we put, the computer will do something. Like for example, if we do add r0 r1 r2, what does that mean? Okay, let's have a look at what does that mean. So suppose that the instruction is given as add r3 r1 and r2. Okay, what is r3 r1 and r2? These are the registers. Register means those which store some values. It's like a variable. Okay, like a box you can think of. In the box there will be some number like 7, another register will have 8, another register will have empty value. So if I want 7 and 8 to get added up and put in this register, so what I will do, I will give this instruction add r3 r1 r2. So r3 is the final value where it will be stored, and what will be stored? The addition of r1 and r2. So r1 and r2 will get added. For example, if it is 7 and 8, 7 and 8 it will be added and 15 will be stored in r3. Okay, so this is what is called as the instruction. What instruction you need to perform, where you need to show the result, which are the two things you need to perform the instruction upon. This is the introduction to the ARM set. Okay, like that many instructions are there. We'll be looking at the different kinds of instructions. The first type is the data processing instructions. What do you mean by data processing? Data is nothing but some information. Okay, data processing registers, it manipulates the data within the register. Okay, it changes the data. Okay, so there are 5 ways in which the data gets changed when we move the data from one register to another register. In that case, a new data comes here, so the move changes the data which was present in this register, right? So it is called as a move instruction. Second is arithmetic, addition and subtraction. Third one is logical instructions, comparing between two, like doing the AND operation or the OR operation or the NOT operation or the XOR operation and so on. Okay, these operations we are doing, that kind of instruction is called as logical instructions. Next is the comparison instructions. Is 7 greater or 5 greater? 7 is greater, right? This comparison thing, this is called as the comparison instructions. Multiply is separate because in multiplication a different kind of algorithm gets used, because it's not as simple as arithmetic, right? In addition and subtraction will require two registers, but multiply will be requiring another register to store the carry bits, right? So those will be performed in multiple steps also, so that's why it is taken as separate. Okay, let's have a look at the first one, which is move instruction. Move means what? It moves the data n into register I. It's as simple as that. Okay, it moves the data n into register r. So suppose that n is a register which has the data 5, and if I want to put the data into r, all I have to give is move r comma n. So whatever is stored in n, it will go to r. I'll repeat, whatever is stored in n, it will go to r. Okay, so you got the point. Move r n means whatever data is stored in n, where it will go? Where it will go? It will go to r. Okay, so r will be having 5. That is the move instruction. This is all you need to know. Next is the barrel shifter. Under the same topic, which is the move, we have a barrel shifter. Okay, basically what barrel shifter does is, before moving the result, okay, I want the result n to be moved to the rd. Okay, so but before that, what I have to do is I have to make some changes to it. For example, if I want to multiply the value n by 5 or 4, whatever value I want to multiply, and that multiplied result should be stored somewhere. So instead of giving a special instruction called multiplication n into 5, and then I will be storing it into a register, and then it will be transferred, instead of all of that, what I will do, I'll do a barrel shifter. Barrel shifter, what it supports is, it will support the logical left shift, arithmetic right shift, and rotation operations. Okay, we'll have a look at it, each of these. Okay, so what it does is, it will do that operation and give us the result. So suppose that I want a number, I have a 10, but I want 100 inside that. So what I will do, I'll multiply by 10 and then I will take it. That multiplication step, who is performing that? That barrel shifter is performing. Okay, so that is what is called barrel shifter. It performs an operation on n before the move command. Now in this example, in this diagram, what you can see is there is a number Rn, means in the register Rn there is a number, for example 10. Another register is Rm, there is a number 3. Okay, and I want the final answer in Rd to be 103, but I have just 10 and 3. So basically what I can do, let's take another example. Here it is 3, I want the final number as 130. Okay, so here it is 10 and here it is 3. Oh, no, this will also not work. I want 40. Okay, 40 I want inside the RD. Okay, and RN has 10 and RM has 3. Okay, so what I should do so that I will get 40 here? What I can do, I'll take 10 from here and keep it as such. This is arithmetic, means 10 plus something I have to add, but I have just 3 here. So barrel shifter I will take and multiply this by 10, so it becomes 30, and that 30 I will take it here. So that 30 plus 10, it will become 40. So in this case, the barrel shifter is used where I want to make some changes to the one of the registers so that the desired result is taken into consideration. Okay, so this is what is the use of barrel shifter. An example we can take in the coding language. So there is a register R5, there is a register R7. R5 has the value 5, R7 has the value 8. Now I want to move into R7 the value which is the left shift of R5. Okay, what is left shift? See, this is a number. Okay, 1 is a number. Okay, so here we have 0001. Okay, and when we do left shift means 1 should come here. This is in binary. Okay, so when 1 will come here, that means it will become 0010, and again if I do left shift, it will become 0100. So as you see, if we convert it into the decimal, this will be 1, this will be 2, this will be 4, this will be 8. One thing you can observe is 1 into 2 is 2, 2 into 2 is 4, 4 into 2 is 8, multiplied by 2, it's all happening. So what do you understand by logical left shift? Left shift means when we do left shift by one space, it gets multiplied by 2. Left shift by another space, it gets multiplied by 4. Means again the previous one gets multiplied by 2. Again left shift, again multiplied by 2. Now if I directly left shift 3 times, it will be 2 power 3. Okay, means 2 into 2 into 2. Okay, get the point. Logical left shift by 3 digits means 2 power 3, like that. Now it is logical left shift and hash 2. Hash 2 means 2 spaces, means twice I have to do it, means 2 power 2 it will become, so it will be 4. So whatever is the value present in R5, which is 5, if I write it in decimal, I mean binary, it will be 101. If I multiply it by 5, or I do logical left shift, it will become 101 then 00, and this one is equivalent to 20. You can verify. Okay, so 20 is the equivalent. So 5 into 4 is 20. So while using this operation, I converted 5 to 20, and that 20 will be stored in R7. So final value in R7 will be 20. Okay, so this is what we use the barrel shifter to convert the register value before transferring it to the other register. Okay, this is the barrel shifter. And in move command, you need to know these two things. Okay, the basic move command, and after that how the barrel shifter works with the diagrammatic representation. Okay, the next one is the arithmetic instructions. Okay, by the term arithmetic, what you can understand, there is addition and subtraction. Okay, so there are two registers R1 and R2, and they are having numbers. Okay, and if you want to add them or subtract them and store it the result in another register, for this purpose we'll be using arithmetic instructions. Okay, so they do the operations on 32-bit signed numbers. So ADC, it is with carry. Add is adding two 32-bit values, and RSB, RSC, SBC, and SUB do the subtraction. Okay, with reverse subtraction as well here. So here are the commands given. Okay, so let's understand using an example. So an example of subtraction will be R0 consists of this value, which is 0, R1 consists of 1, and R2 consists of 2. Now what I have to do is, my task is to subtract R1 from R2, means R2 minus R1 I have to do. So what I will do, I'll do a sub R0 comma R2 comma R1. So in R0, what should be stored? R2 minus R1. This answer will be stored in R0. Okay, so that is the subtraction part, and final value will be 1 here. Why? Because 2 minus 1 is equal to 1 only. And we can use barrel shifter here as well. For example, if R0 is 0 and R1 is 5, but before taking R1, I will be doing logical left shift with 1. So what it will become? 5 it is, so it will become 15, right? And 15 is represented as F. Okay, and then what I will do, I will add it with, sorry, it will not become 15. 5, if we do logical left shift, 5 into 2 will happen, it will become 10. So 10 it will be answer here, and here it is addition, right? So this answer, this R1 value will be added with this answer. This answer is 10 and R1 value is 5. So 5 plus 10 is 15. That will be stored in R0. So R1 will R0 will be having 15, and 15's hexadecimal value is F here. Okay, So this is the result. So this was about the arithmetic instructions. You can use the barrel shifter here as well. Next is the logical instructions. It performs the bitwise logical operators on two source registers. So two registers are there if you want to do the AND operation, OR operation, exclusive or XOR operation, or bit clear operation we have to do. Okay, these are the Boolean operations, right? So if you want to do the logical OR operation, for example, on this one, R0, R1 and R2 is present here. If I want to do logical OR on R1 and R2 and store the value in R0, so what it will happen, R1 is equal to 02040608 and R1 is 10305070. If you do the OR operation in this both, what will happen, OR between these two, 0 and 1, OR will be 1, 2 and 0, OR will be 2, 0 and 3, or will be 3, and so on. So it will fill all the values 1 2 3 4 5 6 7 8, right? So that will be my final answer stored in R0. This is the logical OR operation. Next one is the comparison instructions. Comparison means comparing two numbers, 10 and 12. Which is greater? Tell me which is greater. 12 is greater, right? So this will be the answer for this one. So basically we'll be using these commands, CMN, CMP, TEQ and TST. So these are the same commands for the same purpose of comparing two numbers, but it is slightly different. It works in a different way. Okay, so let's take a simple example for CMP. Okay, compare. So CPSR is current program status register. Okay, ignore this for now. We have two registers with R0 and R9, which each one is having 4 value. Now if we compare 4 and 4, is it equal or not? It is equal. It is equal means the answer is true. Whenever the value is true for the comparison operator, the flag Z will become capital. Z is used to denote if the answer is equal or not, means true or not. Okay, if you do not equal, okay, 4 is not equal to 4, it will become false. So we are trying to see if the value is true or not in the comparison. Whenever it is true, Z will become capital. If it is not true, Z will remain small. Okay, so that will be the change happened here. If we compare R0 and R9, both are same, so it is true, so Z will become capital. Okay, so this is how do we do the comparison operator. Last one is the multiplication. It's also the same thing as the previous ones. We just multiply a pair of registers with two numbers and store them in another register. Okay, so let's take a simple example, MUL, RD, RM, RS. Okay, so this is just a alternate version of the multiplication MLA, means multiply and accommodate. Okay, means what, RM into RS, we will do the value stored in RM register and RS register, whatever it is there, multiply them, add with RN, then store the value in RD. So if you want to add some value after the multiplication, use MLA, multiply and accumulate. And if you just want to multiply, use multiply. That's simple one. Let's have a look at the multiply. And this is related with the sign and unsigned, means the length of the numbers. Okay, so the following example shows the multiplication of R1 and R2 and storing the result in R0. Okay, so this is R0, this is R1, this is R2. We will multiply these two. What is 2 into 2? 2 into 2 is 5, right? Yes. 2 into 2 is 5. No, you idiot. 2 into 2 is not 5. 2 into 2 is 4. Okay, so we'll do the multiplication here and store the value in R0. Okay, so what we'll do MUL R0 R1 R2. When this multiplication answer will be coming, that will be stored in R0, which will be equal to 4. Okay, this is how you write the multiplication, and this much is enough for you to score full marks in this type of question which they will be asking in the exam. Okay, this much only you need to write. And these are just for information. If you can memorize, you can memorize them. Okay, moving on to the second type of instruction, which is the branch instruction. Till now we discussed the data processing instructions, right? Inside that we had 5. Now we have branch instruction, inside which we will have 3 branch instructions. Okay, so what is a branch instruction? Branch instruction basically means, for example, if you are executing a program, in that program one line came in which it is to add 2 numbers. Okay, add 2 numbers. Now how to add 2 numbers, that logic is defined somewhere else. So basically what we do, the main program will stop here, it will go to the other part, it will do this execution, it will come back here. So this is called as branch instruction. It is going to some other branch and executing it. Or else you can understand it in this way also, like a loop. Okay, when a loop is there, it will come till the end, again it will come here. So a branch is happening between this point and this point, so it will keep on going to the same point. So that is a branch. Okay, there are 2 types of branch. And how do we specify it has to go here? By using a label. Okay, so 4 types of branches there: branch with link, branch exchange, and branch exchange with link. Okay, so these are just the working is different, but the basic concept you need to know, which is important from the exam point of view. What is branch? Okay, so basically we will be assigning a label to PC. Label means from where the execution has to continue. For example, if I was executing it here and I have to do the addition, I'll be assigning a label apple here. Okay, then I'll do the addition and I'll come back. Addition is over. Where I have to start from? I have to start from the apple, right? So that's why the label is stored here. So that program counter will start from here and I can continue the execution. So an example for the branch instruction, this example shows a simple fragment of code. Okay, there is a simple fragment of code that branches to a subroutine. This is a subroutine using the BL command. Okay, and to return from a subroutine, if you have to return from the subroutine, you have to copy the link register to PC. Link register is nothing but it will have from where to resume. If you went here, where to resume, that is called as a link register. So BL subroutine, branch to subroutine. Then subroutine means this one. Subroutine will be done. After it is done, where you have to start from? You have to start from here. And where is this location stored? This location is stored in LR, link register. Whenever you go to a subroutine, link register will be assigned to the next instruction. So that when you come back, you will be starting it from here. PC means from where the program counter is there, means from where the next instruction should start. That next instruction is assigned to LR. LR is already here, so it will start from here after the subroutine is done. So this is called as a branch instruction. Okay. Next type of instructions we have is the load store instructions. Okay, this is the third type. First one was what? Data processing. Second one was branch instruction. Third one is load and store. This is very important. Okay, here also we have three types: single, multiple, and swap. Okay, so here in load store, what it will do, it will transfer the data between memory and the process registers. Memory is where we store the data in the system, and process register is the temporary registers where the data is stored for the programming purpose, right? So there are three types: single transfer, multiple register transfer, and swap. So let's have a look at the first one, which is single transfer. Basically in single transfer, one data item will be put in a register and taken out from a register. Multiple will not happen. One data will be done at one time. So for that we have the following. LDR means load word into a register. STR means save byte from a register, and this is a byte, so this is related to a bit and this is related to a byte. Okay, so the address is differed here. Now what is loading, what is storing? Okay, load word into a register. This is memory. Okay, this is my memory. Memory means inside the computer, and this is register which is getting changed always. If I store from memory to register, it is called as loading. If I store from memory to register, it is called as loading. Always we will do it with reference to the register. Loading into a register from where? Memory. Okay, that is means in loading we will be loading to a register. Saving means saving from a register. Okay, always take the reference from a register. Loading to a register, saving from a register. Register some values there, saving from this to where? Into the memory. Okay, so program data is in the register and the main memory is having the main data. Okay, so if you want to do it with the half words, it will be in a half memory address will be there. Okay, so this is the load and store. Now in the example part, if you write LDR R0 and in bracket R1, so what does this do is we are storing the content pointed here into R0. Okay, so basically let me make it again clear. See, R1 is here. Okay, R1, suppose it has the value 300. Okay, and 300 is an address, and there a value stored as 44. Loading means the 44 is there, right? That 44 should come and put in R0. That is loading into a register. Storing means from this register you have to store into a location pointed by R1. For example, R0 has 50 value. Okay, R0 has 50. Where it should be stored? It should be stored which is pointed by R1. R1's value, suppose it is 400. Okay, now 400 is the address where I will be storing R0. 50 will be stored here. Okay, so R1 has the address. In that address, R0 value will be stored, and loading means R1's value will be there, and that will be loaded in R0. Okay, loading into a register and storing to a register, like that. Next is the single means this is single load using the address modes. Okay, now address modes can be pre-index with write back, pre-index and post-index. So basically what it means is in pre-index with write back, the wherever we want to write it. Okay, means for example, if there is a base value, okay, base value is 400. Okay, I don't want to write the value in 400, I want to write it in 404. Okay, so base register has 400 value, but I will add 4 so that it gets written in the 404 register. Okay, I have added it, but base register value will also get changed and it points to 404. That is pre-index with write back. Before writing the value, change the index and save that updated index. That is pre-index with write back. Pre-index only means I am in 400. I want to store in 404. I will add 400. I'll add 4 to it and I'll store the value here. But base index will still point to 400 only. That is pre-index. Post-index means I have stored the value in where the base register was pointing to, and then it is getting changed to the next value, which is 404. So value is stored here and base register is pointing to the next value. So that is post-index. After storing the value, change the index. Okay. So this is about the three types of addressing mode. Now second one was multiple. First one was single transfer, second is multiple register transfer. Multiple also can be done with load and store. For example, I have a bunch of values from 1 to 10. Okay, I have 1 to 10 values. Now this 1 to 10 values I have to store it in another register. So I, instead of putting it one by one, I'll put it together. How I'll put, for example, if each of these register is named, okay, first one is R1, last one is R10. From R1 to R10 I have to load into a register. Okay, so what I will do, I'll do the load operation, load multiple LDM I have to do, and into R0 I have to load, what I have to load, I have to load R1 comma R10, means from R1 till R10 it will be stored in R0. Okay, it is hyphen R1 hyphen R10. So R1 hyphen R10 within the flower braces, this values will be stored in R0. Okay, wherever R0 is pointing to, suppose that R0 is pointing to this value, from here it will be stored in the consecutive 10 locations. Okay, that will be the result happening. Yeah, and store operations also same. If there are values here, you want to store it in some location, you can use this one. Okay, so in this also there will be addressing modes, which is increment after, increment before, decrement after, decrement before. Increment after means after storing the values you have to increment the address, means wherever R0 was pointing to, there only I'll start storing, and after that increment will happen. Next one, increment before means R0 is pointing to here, first increment the value of R0 and saving will start from the next location. Decrement after, decrement before. Decrement after means after storing all the values, decrement one value to point it to the previous location. Decrement before means before storing the values, first decrement and then start storing it. Okay, like that. These are the four addressing modes. Let's take an example for the one of the instruction, which is load multiple in increment after. Okay, now the task is very simple. We have a location pointed by R0. Okay, R0 is pointing to this location. Okay, which is 0001. Okay, now I have to store this value, the next value, the next value. These values have to store in R1, R2, and R3. So my question is, do I need to increment before storing or after storing? My task is to store 1 in 1, 2 in 2, 3 in 3, and R0 is already pointing to this, so I'll not increment first. I'll first store it, then increment. Then increment means what? IA, increment after. Okay, so what I will write the command is R0, and this means write back, means R0's value should change after my execution. So R0 value is pointing to currently this one. Okay, it is pointing to this one. Okay, what will happen? R1 to R3. Okay, whatever is pointing here, that will be stored to R1. Next location of R0 will be pointed to R2 and it will be stored there, and after that location will be pointed to R3 and it will be stored there. So 1 will be stored in 1 and 2 will be stored in 2, 3 will be stored in 3. As you can see, there is 3 to 1 here, which was not there previously. So what happened? We stored it in this place here, and after I have reached the end, then I have to increment, because increment after. So I'll increment from here to the next location, that is increment after. If I don't write increment after, it will stay here only. Okay, now it is write back. Write back means the final value will be updated to the latest location. If I don't put this one, what will happen? Again, this will be reset and it will be pointing here. That is LDM-IA. Now let's discuss LDM-IB. IB means increment before. Increment before means previously it was pointing to this location. Now increment before means before doing any operation, I have to increment this value. So it will be starting from here. Okay. Now R0 is starting from here, and this value will be stored in sorry, R1 R0 was pointing to 80010, right? Yes, it was pointing to here. So it is pointing to here. Okay, increment before means first I have to increment, so I'll increment it. I am now pointing to this, R0 is pointing to this, then start the operation of storing. So I mean operation of loading this value into R1, then this value will be loaded into R2, this value will be loaded into R3. And observe here that here the final value is getting stored as R0 only here. Okay, so the final value will be stored here only, because I have used increment before. So after this point I'll not increment. Why? Because I have already incremented and it will come and get stored here. That's the point. Okay, post condition, which is LDM-IB instruction. In the same way, store also happens. If you want to store these values in this location, you'll be starting to store from here, and you'll be pointing the first starting place where the storing should happen. So this will be stored here, this will be stored here, this will be stored here. Okay, based on increment before, increment after, it is there also. STM-IB, STM IA. Okay, and decrease and before and decrease after also works in the same way. Instead of increasing, we'll be decreasing first. Okay, decrease before means before starting I'll decrease it and start the storing from here. So one will be register R1 will be having this value, register R2 will be having this value, register R3 will be having this value, if you use decrease before instead of increase before. I hope so you got the point. Okay, what I'm trying to say. And the same things can be used in the stack also. Okay, stack means what? First in first out, whatever is sorry, it is last in first out. So last whatever is in, that is the first which will be getting out. So this is the stack operation. So pop means deletion and push means pushing the values. So if this is a stack, pushing the values, that is the push operation. Pop means popping up the last value which was inserted. Okay, and here also ascending is there, descending is there. Ascending means stack grows towards higher memory address. So if this is 0, this is 10, so stack will be inserting like this. Okay, it will be inserting like this, that is growing towards higher memory address. Descending means if this is a stack and insertion happens in this way. First it will be inserted here, then it will be inserted here, then here, then here, then here, and the addresses are 10 to 0. Okay, decreasing way. Okay, to the lower memory address it will be stored. Now when you use a full stack, there are two types of stack: full stack and empty stack. Full stack means in the stack, if it is full here, the last location will be pointing to here. Full stack, wherever it is full at the last. Empty stack means if this is the same stack here, empty stack means which is the next empty location, there it will be pointing to. Just the pointer will differ in the two types of stack. Now there are addressing modes for the operations. FA means full ascending, FD means full descending, empty ascending, empty descending. Based on this, the push and pop can happen. Push is the equivalent to STMFA, which is the equivalent to STMIB, increment before, and the pop means LDMFA, which is equivalent to LDMDA, means load into the memory, decrease after. Okay, decrement after, not decrease, decrement after. Okay, so first we'll load from a register to a memory. Okay, I mean from the register we will load it to a memory, and in that memory it will be, what will happen, it will decrement after it is stored, then it will decrement. Okay, like that. That is the full ascending mode for the pop operation. Why we are decrementing after? Because the last location which is stored, we want to decrement so that it gets popped up like that. Okay, so an example of the stack operation. Now see, the pointer is pointing to this point here, and this is a full stack, so it is pointing to the last full location. Now what I do is, I'll be doing the push operation. I'll be pushing two elements, so it will be stored here and here. So the pointer is pointing to the this location. Got the point? And here is the code equivalent of it. These were the initial addresses, and then what I did, I stored R1 and R4 after the location pointed by stack pointer, which means stack pointer was pointing to 14, right? 14, and after that I have to store 2 and 3. So 2 and 3 got stored here, 2 and 3. Okay, and it is full decreasing means it will start from the higher to the lower, like that. Okay, so that's why it became 2 to 3. See, it was 2 and 3 here, and that order only is specified, but 3 got stored first, then 2, if we go in this way, because this is higher order. Okay, this is lower, this is higher. Okay, this is lower, this is higher. Decreasing means higher to lower it will go. So first 2 will be stored, then 3 will be stored. So this is the post values. In R1 and R4 will be same, because we are just using these values. Stack pointer will be pointing to the last location, which is the where it is stored. Got the point? Okay, so the third one is the swap operation. Swap means what? Swapping the values. If there is A and there is B here, inside A there is 10, inside B there is 12. Swapping means after that A will be having 12 and B will be having 10. Okay, that is called a swap operation. So swap, this is the condition. Which two numbers you want to swap, and which is a temporary memory you will be using to keep the temporary value. For example, if I have suppose that the value in R0 is 0, R1 it is 1. So what I will do? 1 I will store in a temporary register, and 0 I'll store in the register R1, and from the temporary register which had 1, that will be stored in the R0. Okay, so R0 will be having 1, R1 will be having 0. Okay, so it got swapped. So in the same way we'll be doing the same thing. We are specifying the register which is there, and R2 is a address. Okay, this is an address. So this address, what it has is, it has another location. This address has a location. This location we will be using for temporary pointer. Okay, so 1 will be stored here, from the register R1 will be stored here, and in register R1 R0 value will be stored. Okay, R0 value was 0, so it is stored here, and in R0 what should be stored, which is having the R1 value. In R0 what should be stored? The register which has R1 value. Which register has R1 value? This location pointed to, it has R1 value. First operation, it has R1 value, right? R2 which is pointing to, so this one will be stored in then R0. So R0 will be having 1 here, and R1 will be having 0 here. Okay, this was about the register transfers. Okay, this I forgot its name. This the register transfers. Okay, so this was one of the type of instructions. Next type of instruction is the software interrupt instructions. Okay, in software interrupt, what happens? So basically, suppose the software is executing here, Then what happens, I want to interrupt it and do some other operation first, then resume after some time. Like for example, if user is inputting something, the whatever is executing, it should stop, take the user input, then it should continue. So this is an interrupt. Or if I want to debug means checking the value one by one, okay, the program code. So if I want to do that between the program execution, I'll stop the program execution, I'll do the debugging, then I'll resume it. So that is called as interrupt. The thing which interrupts the normal execution is called as software interrupt. During this time, some instructions are performed. Okay, so these are the instructions performed. Okay, the values of the registers gets changed. Okay, here's an example. Here SWI software instruction is pointing to a number 012345 6. What does this mean? This is a debugging software interrupt. Means program is executing, I want to stop the program and observe the values and then continue. So this is an interrupt, I want to stop the program. So what will happen is, this is the initial value of CPSR, which is the current program status register. It is running in user mode, which is the normal execution, and the program counter is pointing to 8000, which is the location. LR means where the program should go after the execution of this program, and R0 means it is having 12 value. Now what I did the software interrupt. Interrupt means for debugging the program execution was stopped. Okay, and the debugging happened, and then after that the program execution was resumed. So here whatever the value is there, that is specifying for the debugging, the operation is stopped, and where it is stopped from 8000. After the operation is performed, it will be in SVC mode, which is the debugging mode, and where it has to go, it has to go to the user mode after this is done. Okay, that's why it is stored in where it has to go. And LR means where it should resume the execution from 8000's next location, which is 8004, it has to resume the execution. R0 is same only here. Okay, and program counter means currently where it has stopped. Got the point? So this is how the software interrupt instructions work. This is one example you can give and explain. Okay, like you can expect full marks for that. Next is the program status register instructions. Okay, now program status register, what does it store? It stores the program status, means where it has located and executed, what are the flags used, and what are the operations performed. All those information gets stored. To make changes to this register, we will be using two methods, MRS and MSR. MRS means move from register to system. I mean move register from system. Okay, move to register from system means from system it will come and store in register. That is MRS, move from system to register. MSR means move to system from register. Okay, did I tell the same thing? Move to register from system, move to system from register. Got the point? This is two reverse things. Okay, move to register from system and move to system from register. Okay, and system means what? CPSR or SPSR, current program status register, or and stack program status register. Okay, status programs. What is SPSR? Stack program status register, I believe. Okay, so basically the main thing which you need to know here is that whenever we need to make some changes to this status register, we'll be moving it to another register, making the change and taking back. I'll repeat, whenever we want to make some changes to this, suppose some operation is performed, I want to remove that operation from this status. So what I will do, I'll take this status, copy in another register, I'll make that change of removing, then I'll again take it back from that register. So to move it to another register, we'll be using the MRS. Okay, so here's an example. I'll take it from here. See, what is there is the instruction is used to clear any bit, like for example masked I bit. So there is an I bit. Okay, there are different bits, I bit, F bit, T bit. This is used to denote different types of values, like Z used to denote if it is equal in comparison or not, right? So those things. Now if I want to make a change to this value it became true. Okay, I want to make it as false. What I will do, I'll take this whole thing into another register. How will I do that? MRS I will do. I'll take this whole thing into a register R1. In this R1 I'll do a operation bit I clear. Okay, so when I do the bit I clear, what will happen, this one will be performed with this one, and what will happen here, that particular bit will be erased. How it will be erased? Whichever bit I want to clear it, I'll make it as 1. Okay, so it becomes clear. So after it becomes clear, it will be stored again in R1, and again from R1 I'll do MSR, so that from register to system it will be stored. Okay, and after that the value here, it will become I smaller. Initially I was bigger here, like that. Okay, you get the point. Okay, what is happening here, I am taking a register, status register, into another register R1, perform the operation and take it back to the original register. That's all. That is the thing which is there in the program status register instructions. Okay, the last type of instruction is the coprocessor instructions. Coprocessor means what? Additional computational capability, which means that there is a processor, it is doing some things, okay, but I want it to increase in the performance, so I'll add some more things, that is called coprocessor. Okay, for that we'll be using the coprocessor registers and a memory transfer. Okay, you want to add the registers or you want to add the memory. Okay, and to or from, you want to store or load, whatever it is, all are possible here. Okay, so an example shows a CP15 register being copied to general purpose register, transferring the content of this to another register so that it increases in the performance. That is called as the coprocessor instruction. This example you can give, you can expect full marks. Last topic is the loading constants. Okay, constants we cannot directly load into a register, so we will load a constant into some other place. From there I will be loading into a register and then I'll be making some whatever I want to do. Okay, so LDR is load the constant into the pseudo instruction, and address means if you want to load the address of the constant. Okay, so here is an example that shows LDR instruction loading in 32-bit constant 0FF. This is the constant. I want to load it into a register. How will I do it? Firstly, I'll specify LDR R0 from here. It should be stored in R0, right? And what is here? Program counter is specified and constant number is specified here. This is a variable. Okay, and what does this variable store? This variable stores the value 0FF. Okay, because I have written here. So it will be having this value. I'm not directly using 0xFF. I'm storing it into a value, and that value I'll be storing it. I'll be loading into a register. So this type of operation is called as loading constants. Okay. That's all for the module 2. If you found this video helpful, please do like and subscribe. It helps me make more videos like this, and thank you so much for watching. I'll see you in the next one.